All right, we're going to pick up in chapter 6, or chapter 1, section 6. Sorry about that. And we had just been solving absolute value equations. And we learned that with the absolute value equation, we've got to get the absolute value by itself, set equal to the other side, and make sure that it is not equal to a negative number, because an absolute value becomes positive. It cannot equal a negative number. If you get that situation, it's a no solution. Now we're going to talk about solving equations with two absolute values. The absolute values of two algebraic expressions are equal. They must either be equal to each other or be opposites of each other. So to solve, you're going to take what's inside. Grab my red pen here. A little smaller. Too small. There we go. You're going to take what's inside the first, and you're going to use what's inside the second, but one of them has to be positive, and then one of them has to be negative, because no matter what's inside the absolute value, it turns into positive. So it doesn't matter if it's equal to the positive version or the negative version, it's going to give you a good answer. So let's look at this practically. Here we've got two absolute values, absolute equal to absolute. And so what we're going to do is we're going to take the inside, for problem A, on the left, the 3x minus 4. We're going to set that equal to the positive version of what's inside the absolute value on the right. And we're going to take 3x minus 4 and set it equal to the negative version of what's on the inside, which is just x. Then we're going to solve both. Okay. Now, it's supposed to be get all the x's on one side, all the numbers on the other. The left side has x and number. The right side just has x. So I'm going to move the 3x over with the rest of the x. Negative 4 equals negative 2x. Divide by your negative 2 to reduce it to 1. Gives you x equals. Negative negative makes positive. 4 divided by 2 is 2. So x equals 2 is one of our answers. Over here, distribute the negative into the parentheses, so 3x minus 4 equals negative x. And then I'm going to move the 3x over again. Negative 4 equals now negative x, and negative 3x is negative 4x. So I'm going to divide by a negative 4. So x equals negative negative makes positive, 1. Now I should plug those in and check them. 2 times 3 is 6, minus 4 is 2. Absolute value is 2. The absolute value of 2 is 2. That works out. Plug in 1. 3x minus 4 is negative 1. The absolute value is 1. If I plug in 1, the absolute value of 1 is 1. So 1 does equal 1. So those check out. So those are my answers. Now let's look at B. I'll do it a different color so you can see the difference. Now remember, we're going to take what's on the left side, 4x minus 10, equals, and we're going to do it equal to what's positive inside on the right. Now what's outside I leave. What's positive, okay, what's inside I'm going to make a positive version of that. And we'll work that one first. So I'm going to distribute the 2. So 4x minus 10 equals 6x plus 2. I'm going to move my 6x over to the left. Negative 2x minus 10 equals 2. I'm going to add my 10. Negative 2x equals 12. Divide by negative 2. X equals negative 6. That's one of my answers. Now the other answer, which I'm going to do in blue so you can tell the difference because I'm getting a little tight on space here. I'm going to take the left side, negative 4x minus 10 equals the 2. Now I'm going to do the negative version of the inside, 3x plus 1. So I'm taking the negative of 3x plus 1, and that's going to be multiplied by 2. So 4x should be a 4, not a 9. Make sure it's a 4. There we go. 4x minus 10 equals 2 times negative 3x minus 1 when I distribute the negative to both. Then I get 4x minus 10 equals, and I distribute the 2, negative 6x minus 2. And now I'm going to solve. Add my 6x. 10x minus 10 equals negative 2. Add my 10. 10x equals 8. Divide by 10. X equals 8/10, or 4/5, or 0.8. All of those are correct answers. Okay, we can plug it in. Negative 6 times 4 is negative 24. Negative 24 and negative 10 is negative 34. The absolute value is 34. Negative 6 times 3 is negative 18, plus 1 is negative 17. Absolute value is 17. Times 2 is 34, so that checks out. Now the 8/10. That one's a little tougher because it's all of the tenths and things, and we can do the decimal one if you want to. Might take a calculator to do. Excuse me. Which is okay. 0.8 times 4 is 3.2 minus 10 is negative 6.8. Turned into a positive is 6.8. Okay, so 6.8. 3 times 0.8 equals 2.4 plus 1 equals 3.4 times 2 equals 6.8. Hey, look at that. Checks out. Okay. So you don't do anything with the stuff on the outside, just the inside piece. You do a positive version and a negative of the whole thing. There's one other thing you have to look out for whenever you're doing absolute value equations. You have to look out for what is called an extraneous solution. Extraneous solution is an apparent solution that must be rejected because it doesn't satisfy the original equation. Basically is plug it in, check it, see if it works. If it doesn't, cross it off. So let's look at solving the absolute value we have here. It's an absolute value all by itself. Okay, so that's check 1. It's set equal to positive stuff on the right so far, so that's check number 2, so that means go forward. So 2x plus 12 equals 4x, and 2x plus 12 equals negative times the whole other side. So I'm going to move my 2x. So I get 12 equals 2x. Divide by 2. So x is 6 is one of my answers. And over here, I'm going to distribute. So 2x plus 12 equals negative 4x. Move my 2x. So 12 equals negative 6x. And divide by negative 6. Negative 2 equals x. So let's plug them in and check. Okay. If I plug in 6, 2 times 6 plus 12, absolute value equals 4 times 6. So that's 12 plus 12 equals 24. Absolute value of 24 equals 24. 24 equals 24. Yes, it does. That one's good. Circle it. Okay. Let's plug in negative 2. 2 times negative 2 plus 12. Ooh. That's supposed to be an absolute value. Equals 4 times negative 2. Well, that's negative 4 plus 12. Absolute value equals negative 8. Can an absolute value equal a negative? No, it cannot. This is a no-no. So we cross that one off. Only one answer actually works. So with absolute values, you really need to check your answers to make sure you don't have an extraneous answer. Okay. One more thing that can happen whenever you're solving with two absolute values. So let's try to solve this one, see what happens. So I'm going to do x plus 5 equals x plus 11, and x plus 5 equals negative times x plus 11. Okay, so let's work the left side one. Well, let's see. If we get our x's on the same side, we're going to subtract x. X minus x is 0, so it leaves me with 5. X minus x is 0, it leaves me with 11. That's what's weird. It says 5 equals 11, but 5 doesn't equal 11. This is a no. So I don't get a solution there. That's a no solution situation. Let's see if the other one gives us no solution. Okay, let's distribute the negative. X plus 5 equals negative x, not plus, minus 11. Add the x over. Okay, so now we're 2x plus 5 equals negative 11. Let's move the 5. 2x equals negative 16. Divided by 2, x equals negative 8. Okay, so we need to check it and make sure it's not extraneous. Negative 8 plus 5 is negative 3. Absolute value is a 3. Negative 8 plus 11 is 3. Absolute value is 3. That checks out, so negative 8 works. So with absolute values, get the absolute value by itself. Make sure it's not equal to a negative. Then pull out the inside of the absolute value and set it equal to the positive version of the right side and the negative version. If you've got two absolute values, same process. Okay, make sure it's not absolute value equal to a negative times an absolute value. That'd be a no. But if it's equal to positive stuff, take the inside of the left, set it equal to the inside of the right, positive, and set it equal to the inside of the right, negative. Distribute that negative to all of the inside. Anything on the outside stays. If you get a nonsense like 5 equals